Welcome to Spring LIB.
Hi everyone. So what we have here is a problem that's going to allow us to use concepts from normal and tangential acceleration in motion and Newton's second law to solve for the quantities that we're asked to solve for. So what we have is a ride whose pivot point is a distance of 4 meters away from the center of rotation. We have a rider, shown here by this dot, who is experiencing normal, tangential, and upward forces. And we know the angle that which the cable makes with the pivot point, theta, to be 30 degrees. Write that here. And we know that the length of, or the distance from the pivot point to the rider is 6 meters. So what we're asked to solve for is the velocity of the rider in the chair, and also the normal, tangential, and vertical force components acting on the rider during this ride when theta is equal to 30 degrees. So what we can do first is just go ahead and draw the free body diagram of our rider. So here we have our rider. Here we have this tension force that is keeping the rider circling the ride. And we also have the weight force. And from trigonometry, this is theta, which is equal to 30 degrees. So by taking our Newton's second law in the normal direction, we see that the net force in N is equal to m times acceleration in the normal direction, which we see is equal to t sine theta, which is 30, minus 80 times v squared all over 4 plus 6 sine theta. Now what we've done here is we've just substituted in for the normal acceleration, which we know to be v squared over r. So we know that this is equal to 0. Therefore we can say that t sine theta, or t sine 30, is equal to 80 v squared all over 4 plus 6 sine theta. Next, what we can do is we can look in the vertical direction, and we see that t cos theta, which is the component of the tension in the vertical direction, is simply equal to the weight force. So that's going to be equal to mg. We know mass to be 80 kilograms, so it's 80 kg times g. What this does is this gives us the tension force, which is equal to 906.2 newtons. What we can do is we can take this value and plug it into here. And what that allows us to do is solve for the velocity. And by solving for v, we can see that v is equal to t sine theta times r, which is 4 plus 6 sine 30, or sine theta, all divided by 80, which is the mass, and you take the square root of that. That's equal to our velocity. So we find that the velocity is equal to 6.3 meters per second. Recall that we're also asked to solve for the normal, tangential, and vertical forces. So what we can do is we can say that the normal force will simply be equal to the person, or the mass of the person. So that's going to be 50 kg times v squared all over r. Similar to before, r is just going to be equal to 4 plus 6 sine theta. So what this gives us is 50 kg times 6.3 meters per second squared all over 4 plus 6 sine 30, which is equal to 7 meters. This gives us a normal force equal to 283 newtons. Next, what we can do is solve for a tangential force. So we know that the net tangential force is equal to m at, but we know that the tangential force is 0 because the ride is going at a constant angular velocity. Therefore, tangential force is equal to 0. Next, what we can do is we can solve for our vertical force, Fb. What we can do is we can say that the net force in B is equal to m AB. We know that this is equal to 0. Therefore, what we can do is we can say that Fb minus 490.5 is equal to 0. And what this does is this gives us that FB is equal to 490.5 newtons. And that's our final answer.